everyone, welcome back. It's great to have you here today. In this video, we are going to go through this paper together. Before we dive in, please make sure you have had a go at these questions. Okay, now let's get started. Okay, so now let's first find out what is 4a. 4a is 4 lots of 4 negative 7, which is 16 negative 28. 5b is 5 lots of negative 3 negative 2. Therefore, it's negative 15, negative 10. Now, 4a subtract 2c is 5b. By rearranging to make 2c the subject, we know that 4a subtract 5b is going to be 2c. We know what is 4a, we know what is 5b. Therefore, 2c should be 31, negative 18. Now, if 2c is 31, negative 18, c is going to be 31 over 2, negative 9. Okay, so now let's have a look at the second question. In this question, it says, if m and n are integers, where m is not equals n, then m plus n greater than m. And we want to disprove this statement. So if we are going to disprove the statement, we can do so by providing a counter example. So let's pick some numbers. If m is 2, n is negative 1. m plus n is going to be 2 plus negative 1, which is 1. And that is smaller than 2. Therefore, the statement is false. Okay, moving on to third question. Now, in this question, we are given the graph y equals x cubed plus 2x squared. Subtract 13x, subtract 4. And we are given the graph in the range of negative 5 and 4. We need to estimate the solution of x cubed plus 2x squared, subtract 11x, subtract 12 equals 0. Now let's compare these two equations. We have x cubed, that stays the same, 2x squared, that is the same. In order to go from negative 11x to negative 13x, we have to subtract 2x on both sides. And we have negative 12, however, the graph given is negative 4, therefore we have to plus 8. So what we need to do now is we need to draw the graph y equals negative 2x plus 8 by plotting some points. And what we have here are 3 intersections, and the x-coordinates of these 3 intersections are our solutions. Moving on to the next one, question 4 is testing set theory. So we are given a universe set, which is a set from number 1 to 14. Q is the set of factors of 24. R is multiples of 6. S is odd numbers. This symbol here means and. In this question, it says 3 is an element of Q and S. Now, Q is a factor of 24, so 3 is a factor of 24, and it's also an odd number. Therefore, 3 is in the set Q intersect S. S dash means it's not odd. R is a multiple of 6. We want to write down the elements of set that is not S, but also a multiple of 6. So what we have here is 6 and 12. Now, n bracket S, that means the number of elements in S. Now, we know 1, 3, 5, 7, 9, 11, 13 are odd numbers. So the order of S is going to be 7. Okay, now a number is chosen at random from the universal set. So that is number between 1 and 14. We now want to work out the probability that this number is in the set R union S. Now R, just remind ourselves, is the set of multiples of 6. S is odd number. So in this set, we have 1, 3, 5, 6, 7, 9, 11, 12, and 13. We know in the universal set, we have 14 numbers. And in the set R union S, we have 9 numbers. Therefore, the probability is 9 over 14. Moving on, given that the number chosen is an odd number, and we want to work out the probability that this number is in the set Q dash. So that means not a factor of 24. So we know it's going to be 5, 7, 9, 11, and 13. There are 5 numbers, and we are given that the number chosen is an odd number. So we have 7 odd numbers between 1 and 14. So the probability is going to be 5 out of 7. Okay, so now let's look at question 5. In this question, we are given a diagram of a sector OABC. It is taken from a circle centered O and a radius 8 centimeters. AC is a chord of a circle. Now we are given that the area of triangle OAC is 16 root 3 centimeters squared. We wanted to work out the area of the shaded segment. So the area of shaded segments is going to be the area of a sector subtract area of triangle. Now we want to give answers in this form, where A is an integer and B, C, D are prime numbers. Let's start from the area of the triangle. We are told that the area of a triangle is 16 root 3. We also know that to work out the area, we need to do a half AB sine theta. Now we know what is A and B. In this case, they are 8. And we can rearrange to give us sine theta is root 3 over 2. Now we need to know our special trig value. This tells us theta is going to be 60 degrees. Now we can work out the area of a sector, which is theta over 360 times by pi times by r squared. Now r squared is 8. Therefore, from here, we can work out the area of a sector is 32 over 3 pi. The segment is going to be 32 over 3 pi, subtract 16 root 3. So what we need to do is to find the common denominator and write them as a single fraction. So as we can see, we can take a factor of 16 out of the bracket. We have 2 pi subtract 3 root 3 over 3. A is an integer, B, C, D are primes, as required. Okay, now moving on to the next question, question 6. We are given a fraction and we need to simplify it so that we can rewrite it in the power of 2. So we want to find y and leave our answer in its simplest form. Because the right-hand side is given as a power of 2, give us the hint that we need to rewrite our right-hand side in the power of 2. So to start with, we can simplify 80 and 20 by dividing numerator and denominator by 20. 8x plus 2 is 2 lots of 4x plus 1. The reason why we wanted to do it in this way is because that now I have root 8 squared and I can simplify that to 8 to the power of 4x plus 1. Now, of course, you can rewrite root 8 in the power of 2. We will be able to get the same answer. Now, we know 8 is 2 root 3. By using laws of indices, we know that this is going to be the same as 2 to the power of 12x plus 3. Now, let's look at the denominator. 16 is 2 to the 4. And again, by using laws of indices, we know that this can be rewritten as 2 to the power of 8x subtract 20. Our fraction can be rewritten as 4 times 2 to the power of 12x plus 3 over 2 to the power of 8x subtract 20. Now 4 is 2 to the power of 2. With the same base, I can add the powers. So we have 2 to the power of 12x add 5 over 2 to the power of 8x subtract 20. Now if I have a to the x over a to the y, we will be able to do a to the power of x subtract y. Now here we have to be careful because we need to put the brackets around the powers. By expanding the brackets, we have 12x plus 5, subtract 8x, add 20. By simplifying our power, we will have 2 to the power of 4x add 25. And therefore, y is 4x plus 25. Okay, now let's have a look at question 7. In this question, we want to write 3 subtract root 5 to the power of 2 in the form of c subtract d root 5. Now we can use Farmer's field to expand the brackets. And in the end, we will have 14 subtract 6 root 5. Now what we need to do is to write this big fraction in the form of e plus root 5 over f. Now in part A, we know what is 3 subtract root 5 squared. And that is 14 subtract 6 root 5. Okay, so now what we need to do is to rewrite root 20 because root 20 is root 4 times 5, which is 2 root 5. So 14 subtract 6 root 5 add 2 root 5 is 14 subtract 4 root 5. Now what we need to do is to multiply the numerator and the denominator by 14 plus 4 root 5. And the reason why we wanted to do this is because now we can use a difference of 2 squares and the denominator now will become an integer, 116. We can rewrite it in the form of 1 plus 58 root 5 over 116. Okay, and then by simplifying it, we will have 1 plus root 5 over 2. Moving on to question 8. Now in this question, we are told that circle C has an equation x squared subtract 2x plus y squared subtract 14y plus 25 equals 0. Now when we look at the circle of equation, what we need is the center and the radius. Now, what we need to do is to complete the square and put the equation in the form of x take away a squared plus y take away b squared equals r squared. X squared minus 2x can be written as x take away 1 squared take away 1. Y squared take away 14y can be rewritten as y subtract 7 squared take away 49. By collect the constant and move it to the other side, we'll have x subtract 1 squared plus y subtract 7 squared equals 25. So in this question, we have the center of the circle 1, 7, and we'll have the radius 5. Okay, so we get a quick sketch. This is our circle. Now we are also told that the point A has coordinates 4, 11. It's on the circle C. The line L1 is a tangent to the C at A, and the line L2 has a positive gradient and passes through A. We don't really know what it looks like. What I'm going to do is just to get a sketch of L2. It might not be exactly where it should be. However, at least that gives us an idea what this problem will look like. And then we are told that the area of the triangle enclosed by L1, L2, and the x-axis is 110. We know the height is 11 from the coordinates of A. Base is going to be 20. And how did we know that? It's because we know the area of a triangle is a half base times height, and that is 110. By rearranging and solving for B, we know B is 20. Okay, so now what we want to do is we want to work out the gradient between the points 1, 7 and 4, 11. It's because we want to find the coordinates of the x-intercept of the line L1. Because L1 is a tangent, we know it's going to be perpendicular to the radius of the circle. So we can work out the gradient. We know that the center is 1, 7. We know that A has a coordinate of 4, 11. Therefore, the gradient of the radius is 4 over 3. Now, the gradient of L1 should be negative reciprocal, which is negative 3 over 4. Therefore, L1 should have an equation in the form of y equals negative 3 over 4x plus c. And we know 4, 11 is on the line. Therefore, by substituting these points back into the equation, we can solve for c, which is 14. So we have to find the equation of the straight line y equals negative 3 over 4x plus 14. So to work out the x-intercept, what we need to do is to let y be 0 and solve for x. In this case, we have x to be 56 over 3. So we know this point here is 56 over 3. We know the length of the base is 20. Therefore, to work out the coordinates of this point here, we will need to do 56 over 3, take away 20, which is negative 4 over 3. So as you can see, my sketch initially isn't correct. This point should be in the negative x-axis, but it doesn't matter, because what we need to do now is we need to work out the gradient of L2. We now have 2 points. This x-intercept, which is negative 4 over 3, 0, and also point A, 4, 11. So the gradient is 33 over 16. And then because we know it's x-intercept, what we want to do is to substitute negative 4 over 3 and 0 back into the equation. You can use 4 and 11, you will be able to get the same answer. And here we worked out c is 11 over 4. Therefore, y is 33 over 16x plus 11 over 4. That's it for today. Well done for making it through to the end, especially if you have done the questions yourself. Remember, maths isn't a spectator sport, and we have to keep practicing to be more fluent. Happy revising, and I'll see you in the next video.